Most organizations think security is a checklist, MFA, EDR, a pile of policies, and a dashboard that's mostly green. That setup feels like control. It isn't. It's coverage. And coverage doesn't equal resilience. This episode is about the uncomfortable shift leaders have to make, from buying controls to designing trust, and from chasing no incidents to engineering fast containment and recovery. We'll anchor it in three Microsoft realities: Entra governance and identity threat detection, continuous access evaluation, and defender signals routed into ServiceNow. Because the goal is decision speed, not feature completeness. Why well-secured organizations still get breached. Here's what most people miss. Breaches don't happen because an organization forgot to buy a product. They happen because the organization never updated its trust model. Security teams deploy controls. The business keeps operating on assumptions that were true 10 years ago. That the network is a boundary, that authentication is a finish line, that permissions represent intent, and that alerts are the same thing as response. Those assumptions don't fail loudly. They decay quietly. And attackers don't need to break in anymore. They walk the pathways you already built. A modern breach story usually starts with identity, not because identity is weak, but because identity is everywhere. Cloud, SaaS, APIs, automation, contractors, service accounts, and now agents. Identity isn't the directory, it's the control plane. That distinction matters because your control plane isn't protected by the existence of controls. It's protected by whether those controls enforce your intent. Most well-secured environments are rich in prevention and poor in constraint. You see it in the gap between authentication and authorization. They might have phishing-resistant MFA and still have reckless entitlements. They might have conditional access policies and still allow broad access packages that never expire. They might have privileged access tooling and still tolerate standing power because approvals are slow and exceptions are easier. Attackers understand this. They don't fight your MFA head-on if they can steal a token after the MFA challenge. They don't brute force a firewall if they can use a perfectly valid identity to call an API. They don't need to exploit a vulnerability if the environment already grants the privileges that do the damage. So when leaders ask, how did this happen? We had everything turned on. The correct answer is you had controls, but you didn't have enforced trust. Then there's the green dashboard problem. Dashboards show deployment state, not risk reality. We enabled feature X is not the same as feature X is constraining the right pathways. A tenant can show high compliance while still carrying structural exposure. Dormant accounts, stale guest access, over-permissioned applications, service principals with broad rights, and exception policies that never die. Controls drift because organizations drift. Entitlements accumulate, policy exceptions become permanent, and the system keeps working, which is exactly why the risk stays invisible. This is why compliance isn't the finish line, it's a snapshot. And snapshots don't stop moving systems from eroding. A breach, in that sense, is not a moral failure, it's system behavior. Systems optimize for throughput, people optimize for getting work done, security teams optimize for what they can measure. If the organization measures how many controls are deployed, it will get deployed controls. If it measures how fast can we contain identity-driven incidents end-to-end, it will build the ability to contain them. That is the difference between prevention theater and resilience. And AI doesn't make this easier, it makes it faster. AI amplifies the speed of both offense and defense. It reduces the cost of generating phishing, social engineering, and automation, but it also reduces the cost of correlating signals, summarizing incidents, and orchestrating response if you design the system to act on those signals. If you don't, AI just accelerates your alert volume. You end up with higher telemetry, more noise, and the same decision latency. That is not progress, that is expensive confusion. So what does well-secured but still breached look like in executive terms? It looks like an organization that can detect but can't decide. Or can decide but can't enforce, or can enforce but can't recover quickly. Each handoff adds time. Each manual step adds delay. Each exception adds ambiguity. Over time, you don't have a deterministic security model anymore. You have conditional chaos. And that's why organizations still get breached. Not because they lacked tools. Because the trust system was never engineered as a closed loop. Identity signals into policy decisions, decisions into enforcement, enforcement into response, response into recovery, and recovery into learning. Without that loop, every control is just a static gate on a dynamic highway. Redefining success. From prevention fantasy to resilience discipline, leaders keep getting trapped by a definition of success that sounds reasonable but collapses in practice. Fewer incidents. It's a nice headline. It's also not a strategy. Prevention matters. Nobody's arguing for neglect. But prevention is probability management. It reduces the likelihood of an incident. Resilience is impact management. It reduces the cost, the downtime, and the organizational confusion when the incident happens anyway. That distinction matters because probability is never zero, and the business still has to operate while you're cleaning up. The uncomfortable truth is that the goal is not no breaches. The goal is bounded failure. Bounded failure means the system anticipates compromise and limits what a compromised identity can do, how far it can move, and how long it can persist. It treats incidents as inevitable system states, not unexpected moral violations. And it builds the muscle to contain those states quickly and repeatedly. This is where security programs get honest. A prevention-first program tends to behave like this. Deploy more controls, tighten policies, increase friction, and hope the incident curve goes down. Sometimes it does. But the second-order effect shows up later. The business finds workarounds, the exceptions pile up, and security becomes a queue. You've improved security in the dashboard sense while increasing organizational entropy in the real sense. A resilience-first program behaves differently. It assumes compromise, designs for rapid revocation, reduces standing privilege, automates containment steps, and rehearses decision-making. It doesn't chase perfect defense. It builds repeatable recovery. If you want board-facing language for this, don't talk about products. Talk about 3 outcomes: continuity, trust preservation, and decision speed. Continuity is obvious. Can the business keep operating, or does an identity incident turn into a multi-day outage because nobody can tell what access is safe? Trust preservation is less obvious but more expensive. Can customers, partners, and regulators believe you're in control during the incident, or does the story become, we didn't know what we had, so we shut everything down? Decision speed is the actual multiplier. How fast can the organization detect, decide, and enforce end-to-end without a dozen handoffs and 3 committees? This is why MTTR is not SOC trivia, it's executive telemetry. Mean time to respond, or recover depending on how you define it, turns an abstract security posture into a measurable operating capability. It forces the right conversations. Who has authority to disable an identity? Who can revoke access across critical apps? Which actions are automated? Which require approval, and why? Where are the manual steps, and what risk are those steps supposedly managing? And it exposes the usual lie. We can respond quickly. Most organizations can respond quickly if the right person is awake, available, and empowered. That is not a capability, that is a dependency. Resilience discipline replaces heroics with design. It builds the response pathways before the incident, when everyone is calm and rational, instead of inventing them mid-breach when fear and politics take over. It also acknowledges a basic system law. Every manual handoff is a latency generator. Every exception is an ambiguity generator. Every ambiguity increases blast radius because people hesitate and attackers don't. This is also where AI is either your advantage or your tax. If AI is only used to summarize alerts, you get prettier descriptions of the same delays. If AI is used to compress the detect-to-decide phase and trigger auditable, reversible containment actions, then you get something that looks like real resilience. Less time spent arguing about what's happening, more time spent making it stop. So success needs a different definition. Success is not, we didn't have incidents this quarter. That's weather, not engineering. Success is, when identity-driven incidents occur, and they will, the organization contains them in business time, recovers without panic, and learns without repeating the same failure mode. That's resilience. And once you adopt that definition, the rest of the strategy becomes obvious. You stop chasing control coverage and start designing the trust system that controls are supposed to enforce. Identity is the control plane, not a directory. Most organizations still talk about identity like it's a shared phone book, a place where users live, a place where groups live, a place you sync to so Microsoft 365 works. That mental model is obsolete. Identity is not a directory. It is the control plane for the enterprise. It is the distributed decision engine that decides who can touch what, from where, using which device, under which conditions, with which level of confidence. Every time an employee opens a file, a workload calls an API, a contractor accesses a project site, or an admin attempts a privileged action, the business is not logging in. The business is running an authorization decision. And the uncomfortable part is that the system makes those decisions continuously, at scale, across hundreds of services, with a default posture that does not care about your intent. It cares about your configuration. This is why identity strategy is not an IT topic, it's operational architecture. The control plane is where business workflows become enforceable rules. If you design it well, autonomy becomes safe. If you design it poorly, autonomy becomes an incident. This is also why the network stopped being your boundary. Networks are still useful. They still matter for segmentation, routing, inspection, and reducing exposure. But they are no longer the thing that defines inside. Cloud and SaaS dissolved that assumption years ago. Users sit on unmanaged networks, devices roam, apps live outside your perimeter, and internal traffic often never touches your infrastructure. So trust moved. Not because Microsoft had a marketing moment, but because the architecture forced it to move. Trust now attaches to claims, who the subject is, what the device looks like, how risky the behavior appears, what the session is doing, and what the resource is. In NIST terms, every access flow becomes subject, policy decision, policy enforcement, resource. Leaders don't need the diagram, they need the implication. Authorization is now the primary business risk surface. And that surface is huge. It's humans, yes, but it's also service principles, managed identities, automation accounts, connectors, third-party apps, and increasingly AI agents that act on behalf of users. This is where the human-machine blur becomes a governance problem, not a futuristic curiosity. Machine identities can outnumber humans dramatically in real enterprises, and they don't complain when you over-permission them. They just keep running, quietly, perfectly, until they're abused. When identity is the control plane, then security maturity becomes less about how many tools you bought and more about how accurately you can answer a few basic questions. Who has access? Why do they have it? For how long? Under what conditions? And what happens when those conditions change? Most organizations can answer the first question incompletely, the second question narratively, the third question rarely, and the fourth question with a policy document nobody enforces. The last question is the one that decides whether you have resilience or just optimism. Because identity isn't only about allowing access, it's about revoking it fast. In a directory mindset, revocation is an administrative event. Someone disables an account, someone removes a group membership, someone closes a ticket. In a control plane mindset, revocation is a containment mechanism. It is part of incident response. It is supposed to happen in business time, not IT time. This is also why the identity plane is where governance either exists or it doesn't. Governance isn't a compliance activity you do annually. Governance is the mechanism that prevents entitlement drift from turning into permanent overpermission. Drift is what happens when every joiner, mover, leaver, contractor, and exception creates a small, reasonable access decision, and nobody ever takes it back. Over time, the organization doesn't have access by design. It has access by archaeology, and the control plane preserves all of it. So when leaders say, we trust our people, that's fine, but the system doesn't trust people. It trusts claims and permissions. If permissions don't reflect business intent, then the system will authorize things the business never consciously approved. That's not a security failure. That's predictable system behavior. Once identity becomes the control plane, you stop asking, did they authenticate? And you start asking, what does this identity allow them to change, exfiltrate, approve, disable, or persist? That's where business impact lives. And that is the transition point for the rest of this episode. The failure mode is not login, it's authorization and entitlement drift. Authorization failures beat authentication failures. MFA can be perfect and you can still lose. That sentence annoys people because MFA is the sacred cow of identity security. And it should be. Strong authentication removes an entire class of cheap attacks. But authentication is a gate. Authorization is the map. If the map is wrong, the gate doesn't matter. Most incident reviews obsess over how the attacker got in. The more useful question is what the attacker could do after they were in. That's authorization, that's entitlements, that's the permissions graph you built over years of reasonable decisions and never revisited. And the real failure mode is that authorization errors look like normal business. A privileged user downloads data, an automation account exports content, a service principal reads a directory, an admin disables a control. These are all legitimate actions in the right context. That's why authorization failures beat authentication failures. They hide inside allowed behavior. They're not break glass events. They are business-as-usual events performed by the wrong actor at the wrong time for the wrong reason. This is also why token theft is so effective. The attacker doesn't need to defeat authentication if they can reuse the session after authentication. Now the system sees a valid token, and the policy engine does what it was configured to do. Authorize. Your expensive identity controls become irrelevant because the attacker is no longer trying to log in. They're trying to act. Which brings us to privilege creep. Privilege creep is not a misconfiguration. It is an organizational default. Every organization hires, promotes, reorganizes, uses contractors, launches projects, and grants temporary access to get work done. Access accumulates because removing access costs time and creates risk of breaking something. So people avoid it. Over time, the default posture becomes keep access unless there's a reason to remove it. That is backwards, but it feels safe operationally, so it persists. This is where least privilege becomes a slogan instead of a system property. Least privilege is not something you declare. It is something you enforce through lifecycle design, time limits, approvals, reviews, and clear ownership. If those mechanisms aren't built into the way access is granted, the organization will drift toward maximum privilege over time. Always. That's not cynicism. That's entropy. And privilege creep isn't limited to humans. Non-human identities accumulate faster because they don't show up in org charts and they don't rotate roles. An application gets permissions for a project. The project ends. The permissions remain. A connector gets broad graph access because it needed it once. Nobody narrows it later. These identities are quiet, powerful, and rarely reviewed. They are ideal attack infrastructure. So when leaders think identity risk, they picture stolen passwords and phishing. That's the entry point, not the impact surface. The impact surface is who can approve spend, who can access regulated data, who can create or modify conditional access policies, who can grant app consent, who can create new identities, who can change audit settings, and who can disable the tools you rely on to detect compromise. In other words, the risk concentrates in change authority. If an identity can change the environment, then that identity is effectively part of your control plane. And control plane identities need different rules, reduced standing privilege, stronger session constraints, more scrutiny, and faster revocation. This is also where over-permission becomes business process debt. IT didn't accidentally grant broad access. The business demanded speed, and the easiest way to deliver speed was to grant access broadly and hope nobody abuses it. That decision doesn't show up as a line item. It shows up later as incident cost, audit friction, and emergency cleanup when the access graph is too messy to trust under pressure. And the most expensive moment to discover authorization debt is during an incident, because now you can't answer simple questions. If we disable this account, what breaks? If we revoke this app's permissions, what stops? If we remove this group, which business process fails? So you hesitate, you negotiate, you open tickets, you call the system owners. Meanwhile, the attacker keeps moving. That's why authorization failures beat authentication failures. They don't require sophistication. They require patience and a permission path. So the leadership takeaway is blunt. If you want resilience, you need to manage authorization as a first-class asset. Not a byproduct, not a quarterly spreadsheet, a living decision model. And this is the transition point. If identity is the control plane and authorization is the primary failure mode, then identity governance is where strategy becomes real, because it is the mechanism that turns who should have access into enforceable, reviewable truth. Identity governance as a business discipline. Identity governance is where security stops being a collection of settings and becomes a management system, not a tool, a discipline. Because governance answers the only questions that matter in a breach. Who should have access? Why do they have it? For how long? Under what conditions? And who is accountable when those answers are wrong? Most organizations treat those as documentation questions. They are not. They are design questions. If the organization can't express intent in a way the control plane can enforce, then the control plane will default to what it always defaults to. Whatever grants access and avoids outages. That's why governance has to be owned like finance, not like a project. Finance doesn't turn on budgeting and declare victory. It runs a cadence, controls, approvals, reconciliation, audits, and corrective actions. Identity governance needs the same shape. Otherwise, access becomes a one-way valve. Granted quickly, removed slowly, reviewed rarely. That's not a security posture, that's entitlement inflation. So start with the foundational misunderstanding. People think governance is about saying no. It isn't. Governance is about making yes safe. It creates predictable pathways for access so the business doesn't need informal workarounds, shared accounts, or permanent exceptions. It is the system that turns autonomy into something you can tolerate. This is also why joiner, mover, leaver is not an HR workflow. It is the access supply chain. Joiners are easy. The organization knows they need something, so it provisions access. Movers are where damage starts. People change roles, projects overlap. People keep their old permissions just in case, because removing access might break a process. So access accumulates. Levers are the obvious part. Accounts get disabled, that's table stakes. But the real governance failure is that movers and temporary workers are treated like edge cases. In most enterprises, contractors, partners, and vendors are not edge cases. They are core operating capacity. That means their identities are first-class risk. Their access has to be time-bound by default, with explicit sponsorship and an expiration date that actually expires. If access doesn't expire, it is not governed. It is merely granted. And that's the difference between access reviews as a checkbox and access reviews as a control loop. An access review is not a spreadsheet exercise. It is the mechanism that forces intent to be restated. If nobody can explain why an identity still needs access, that access is debt. If the reviewer can't confidently remove access because nobody knows what it impacts, that's not a reason to keep it. That is evidence the system has become ungovernable. Governance is also where least privilege becomes practical. Least privilege isn't achieved by telling people to have less access. It's achieved by designing access as a package, scoped, conditional, and temporary. Access packages, approval paths, and periodic recertification are not extra process. They are how an organization prevents privilege creep from becoming an incident response problem. Now apply that logic to privileged access, because that's where business impact concentrates. Privileged access governance is not just admin roles. It is any identity that can change data, change systems, change controls, or change other identities. Those identities must be designed around two truths. Standing privilege is risk, and manual elevation is a latency generator. So the discipline is reduce standing privilege, make elevation fast and auditable, and enforce expiration without negotiation. If elevation requires 3 days and 5 approvals, people will bypass it. If it requires 5 minutes and leaves a perfect audit trail, people will use it. Systems train behavior. This is also where separation of duties stops being a policy statement and becomes a control plane property. The person who requests access should not be the person who approves it. The person who deploys should not be the only person who can disable logging. Governance is where those boundaries become enforceable, not aspirational. And one more uncomfortable truth, governance has a licensing model, but it also has an ownership model. Someone has to own access decisions the way someone owns spend. That means business owners for resources, not just IT, not the security team. The security team enforces. The business defines intent. Because when an identity incident happens, you don't need more dashboards, you need authority. So identity governance as a business discipline is the mechanism that turns identity from a sprawling permission graph into a manageable decision system. It creates bounded access, predictable change, and fast revocation. And that's the transition point. Once governance exists, identity becomes a foundation you can build on. Without it, every advanced control you add is just another policy layered on top of drift. Scenario 1. Entra ID. Identity governance plus ITDR as the foundation. Scenario 1 is Entra ID done the way leadership assumes it already is. Governance plus identity threat detection and response. Treated as a control plane capability, not a portal someone logs into when they remember. Start with the clean definition. Entra is not where identities live. Entra is where trust decisions compile. It takes signals, applies policy intent, and issues the tokens that let humans and machines act inside your business. When that engine is governed, you get bounded access. When it isn't, you get an authorization lottery with a nice UI. So the foundation is two linked disciplines. First, identity governance. This is the part that answers, should this identity have this access, and forces time into the equation. Access packages, expiration, sponsorship, reviews, privileged elevation with justification. The goal isn't bureaucracy. The goal is to stop entitlement drift from becoming your default security model. Second, ITDR, identity threat detection and response, is the part that answers, is this identity behaving like itself, and how fast can we contain it when it doesn't? Not as a SOC hobby, as an operating requirement. Most organizations treat identity telemetry like a forensic archive. Sign-in logs, audit logs, risky users, risky sign-ins. Useful, but not decisive. ITDR is decisive. It's the shift from we can investigate later to we can revoke now. Because identity incidents are not technical events. They are business events with business blast radius. The attacker doesn't want your login page. They want your approval chains, your data export paths, your automation identities, and your admin surface. So what does Entra governance plus ITDR actually look like in practical terms without turning this into a configuration tutorial? It looks like the organization treating access as a product with a life cycle. A new contractor needs access to a project space. They request it through an access package. The package is scoped to what the contractor should touch, not what's convenient to grant. It requires a sponsor who is accountable. It expires automatically. And there is a review cadence that doesn't depend on someone remembering. That seems simple. Here's the weird part. It is rare. Most contractors get access via group membership. The membership doesn't expire. The sponsor changes jobs. The project ends. The access remains. That's not malicious. That's drift. And drift is the raw material of breaches. Now layer in privileged access. Entra PIM is not a nice to have. It's the mechanism that prevents standing power from becoming standing exposure. If an identity can change conditional access, modify app consent, create new service principals, reset credentials, or turn off logging, that identity is part of your control plane. Control plane power cannot be permanently assigned and still be called least privilege. It becomes inherited risk. So the model is eligible by default, active only when needed, time-bound always, and auditable without effort. If elevation is slow, people bypass. If elevation is fast and logged, people comply. Your design trains your culture. Now the ITDR half. Identity incidents rarely announce themselves with a single obvious alert. They show up as weak signals, unusual token use, a sign-in that's technically valid but behaviorally wrong, a new OAuth app consent that shouldn't exist, an admin role activation at an odd time, an account that starts enumerating directory objects it never touched before. The system has those signals. The question is whether you connected them to response. This is where Entra becomes an execution layer, not a reporting layer. Risk signals can drive policy actions. Session risk can trigger step-up requirements. Compromised accounts can be disabled. Tokens can be invalidated, privileged sessions can be constrained, and the moment you can do that quickly, you change the economics of an attack. Because the attacker's best advantage is time, and governance is what makes response safe. Without governance, every containment action becomes political. If we disable this account, will payroll break? If we revoke this app, will the sales team lose access? So the organization hesitates. Governance reduces that hesitation by making access intentional, scoped, and owned. You can be decisive because you understand what normal access looks like. There's also a 2026 reality leaders should not ignore. Entra is tightening the rules around application identities, and service principal-less authentication behavior is being retired. That is not a nuisance. That is a forcing function. It's Microsoft telling you in policy that invisible identities don't get to exist anymore, which is the point. Scenario 1 is the foundation because it restores determinism. It makes access time-bound, it makes privilege temporary, it makes ownership explicit, and it turns identity signals into actions instead of evidence. Then you can build zero trust that actually works because now your trust model has teeth. Zero trust is not a product rollout. Zero trust is where a lot of security programs go to die because it gets treated like a procurement event. A vendor pitches a zero trust solution. The organization buys licenses. Someone turns on conditional access. A slide gets shown to the board. And everybody quietly agrees the journey is complete. It isn't zero trust is not a product. It is not a portal. It is not a single policy set. In architectural terms, it is a replacement for your old trust assumptions. The idea that inside means safe, that authenticated means trusted, and that compliant means controlled. Zero trust says none of that is true by default. Trust has to be earned continuously, per request, and revoked when reality changes. That distinction matters because product rollouts create coverage. Zero trust requires behavior change in the system. The foundational misunderstanding is that people translate never trust, always verify into add more prompts. More MFA prompts, more approvals, more blocks. That's not zero trust, that's friction. Zero trust done properly reduces friction for normal work and increases constraint for abnormal work. It does that by making policy decisions dynamic, contextual, and enforceable close to the resource. That's the NIST model in plain language. A subject requests access, a policy decision happens using real signals, and a policy enforcement point applies that decision. And that loop never stops existing just because the user passed a login screen once. This is why the phrase "we turned on conditional access" is such a warning sign. Conditional access is a policy engine. It's powerful. But if the program around it is built on exception culture, shared responsibility gaps, and unowned entitlements, then conditional access becomes conditional chaos, a pile of policies that look sophisticated and behave inconsistently. The system doesn't degrade because it's malicious. It degrades because organizations are. They merge, they reorganize, they acquire, they ship new apps, they onboard third parties, they add automation. And every one of those changes generates just one exception. Remember this detail, it's going to matter later. Exceptions are entropy generators. Every exception is a trust assumption you are choosing not to enforce. It becomes a permanent alternate pathway unless you govern it like a liability, expiration, justification, and review. If you don't, your zero trust program becomes a museum of past urgency. Nobody knows which policies still matter. Nobody knows which applications rely on them. And when an incident hits, you cannot act decisively because you can't predict the blast radius of enforcement. That's why zero trust is not a technical rollout. It's an operating model. Operating model means ownership boundaries are explicit. Someone defines policy intent. Someone implements it. Someone monitors drift. Someone owns exceptions. Someone is accountable for outcomes, not configuration. And in most organizations, that's exactly where the program fails. Identity teams own identity. Endpoint teams own devices. Network teams own connectivity. Application teams own uptime. Security teams own alerts. Nobody owns trust end-to-end. So the attacker gets gaps between teams, always. A real zero-trust transformation collapses those gaps by defining the trust system as one loop. Signals into decision, decision into enforcement, enforcement into response. It becomes less about do we have the feature and more about does the system reliably constrain the pathways that matter. This is also where leadership has to stop rewarding the wrong behavior. If teams are punished for outages and not punished for drift, they will choose drift. If teams are rewarded for fast delivery and not rewarded for revocation discipline, they will accumulate permissions. If security is measured by how many requests it blocks, it will block more, and the business will root around it. Zero trust done right has a different success condition: safe autonomy. People should be able to work quickly because the system makes low-risk work easy and high-risk work controlled. That requires two things leaders rarely fund explicitly: decision quality and enforcement speed. Decision quality comes from identity governance and clean entitlement design. Enforcement speed comes from capabilities like continuous access evaluation and automated response loops. Without those, zero trust stays a diagram, a beautiful policy model with no runtime authority. So the product rollout mindset needs to die. What replaces it is a program mindset. Trust assumptions are explicit, exceptions are governed, sessions are continuously evaluated, and revocation happens fast enough that it matters. And once you accept that, the next point becomes obvious. Trust doesn't decay at login. It decays continuously inside the session. Trust decays continuously, not at login. Most organizations still design trust like it's a moment in time. You authenticate, you pass MFA, you're good. Then you get a token, and that token becomes a little permission slip that travels with you for hours. That model made sense when the network was the boundary and sessions were short. In cloud and SaaS, it's backwards. The reality is that the session is the attack surface, not the login screen, because the attacker doesn't care about proving who they are. They care about inheriting what you already proved. If they can get hold of the session token or the refresh token, they're not trying to authenticate anymore. They're trying to operate as you after the platform already granted trust. This is why we have strong MFA can be true and still irrelevant to the event that hurts you. It's also why leaders keep hearing the same sentence after incidents. The user successfully completed MFA. Yes, and then the session lived long enough to be abused. So the core shift is this: authentication is not the end of trust. It's the beginning of a continuously evaluated relationship between an identity, a device, a session, and a resource, and that relationship decays. Sometimes it decays because the device posture changes. A laptop goes from compliant to not compliant. An endpoint alert fires, a risky sign-in is detected, a user is disabled, a role assignment changes, or a credential reset happens for suspected compromise. Those are all state changes that should alter trust immediately. But in a point-in-time model, none of them matter until the session naturally expires. That gap between the world changed and enforcement caught up is where modern incidents live. It's the difference between knowing a door should be locked and waiting 8 hours for the lock to engage because the keycard still works. This is where it gets uncomfortable for leadership because IT time is not the time unit that matters. Business time is. If it takes you 6 hours to revoke access because you rely on token expiration, the attacker has 6 hours of clean runway. They don't need persistence. They need time. And your organization usually gives it to them because it designed trust as a single event, not a continuous state. Now layer in the things leaders don't see. Sessions aren't only for humans. Workloads have sessions, automation has sessions, integrations have sessions, third-party apps have sessions. And these identities often have broader permissions because someone wanted the workflow to just work. When those sessions are abused, you don't get a helpful prompt or a user complaint. You get silent, high-throughput actions that look like normal system activity. That's the human-machine blur, operationalized. So when people say continuous verification, they tend to imagine constant MFA prompts. That's the wrong mental model. The system doesn't need to keep asking the user to prove they're human. The system needs to keep validating whether the conditions that justified access still exist. In zero-trust terms, the policy decision point should not be consulted once and then ignored. It should stay relevant. It should be able to say, that session was valid, but now it isn't, which implies something simple and brutal. Trust must be revocable, not in an annual access review, not in a ticket queue, not after a meeting, revocable in near real time and in a way your critical apps actually honor. Because the most expensive form of security control is one that detects risk and cannot enforce consequences quickly enough to matter. This is also where exception culture quietly destroys you. If you've carved out bypasses for business-critical apps, or you allow legacy auth because it's complicated, or you exempt privileged identities because they can't be disrupted, you have effectively declared that the most important pathways are the least governable. That's not a security program. That's a liability register you refuse to name. And the reason this matters to leaders is not philosophical, it's operational. If trust decays continuously, then your organization must be able to revoke continuously. Otherwise, you're running a probabilistic security model. Sometimes revocation happens fast, sometimes it doesn't, and you just hope the attacker lands in the slow lane. So the aha to hold on to is this. Resilience in identity-driven incidents is mostly about collapsing the time between a trust decision changing and enforcement taking effect. That's why the next scenario matters. Continuous access evaluation is where zero trust stops being a diagram and starts being lived reality. Scenario 3. Continuous access evaluation, CAE, as lived zero trust. CAE is what happens when an organization stops pretending that access granted is a permanent state. It is not. It is a temporary decision that should collapse the moment the conditions behind it change. CAE is the mechanism that makes that collapse real and fast in the Microsoft ecosystem, not as a concept, as runtime behavior. Here's the simple version. CAE lets Entra tell participating applications, this session is no longer acceptable, and have the app enforce that in near real time instead of waiting for token expiry. That's the gap it closes, decision versus enforcement. Most security programs have decent decision making. They know when something is risky. They can flag a user. They can disable an account. They can mark a sign-in as high risk. They can detect a device falling out of compliance. But then nothing happens quickly enough to matter because the user session keeps running. CAE is how you stop granting attackers the courtesy of time. Why leaders should care is straightforward. It converts trust revocation from an administrative workflow into an operational control. It turns we noticed into we contained, without a help desk ticket and without waiting 6 hours for a token to die naturally. But CAE is not magic. It's a contract. Entra can emit the signal. The application has to honor it. And that's where reality shows up. Microsoft services like Exchange Online, SharePoint Online, Teams, and others support CAE in specific ways. Many third-party SaaS apps don't. Some claim they do, but implement it partially or inconsistently. So we enabled CAE is not an end state. It's the start of verifying which of your critical applications actually behave like they live in a zero-trust system. That distinction matters because CAE creates an uncomfortable inventory problem. Which sessions can you actually revoke quickly across the apps that matter? This is where leaders get leverage because CAE forces a clean separation between two types of work. First, the policy work, deciding which events should trigger revocation and for which resources. Account disabled, password reset, risk level elevated, device non-compliant, role change. Those are business decisions framed as security conditions. Second, the application work, ensuring critical apps honor revocation signals and that your user experience doesn't collapse into constant re-authentication. Now, the part nobody likes, exceptions. CAE works exactly as well as your exception governance. Every time someone says don't enforce this for executives or exclude this app because it breaks, you've created a permanent bypass around your revocation model. And bypasses don't stay rare, they replicate. This is where CAE exposes the program's maturity. If exception handling is informal, CAE becomes another half-deployed capability. If exception handling is governed, expiration, justification, review cadence, CAE becomes a control you can trust. There's also a dependency most people miss. CAE pushes you toward cleaner identity architecture. If your environment still relies heavily on legacy authentication patterns or your application estate treats tokens as long-lived entitlements, then CAE becomes a compatibility argument instead of a security capability. That's not a reason to avoid it. That's a reason to treat application modernization as part of security resilience because the business depends on revocation speed. A concrete scenario makes this obvious. An employee's account gets flagged as high risk after anomalous activity. In the old model, the security team disables the account, but the attacker's token remains valid in a browser session connected to SharePoint or another SaaS service. The attacker continues downloading data until the session expires. The organization responded, but impact continued. With CAE, disabling the account or changing the risk state can trigger a near real-time re-evaluation. The app receives the revocation signal. The session is forced to re-authenticate, and the attacker's runway collapses. The cost of compromise becomes bounded, not because the attacker failed to get in, but because they couldn't stay. That is lived zero trust. Not a poster, not a slide, a system that revokes trust inside the session. And CAE has a second-order benefit that leaders tend to miss. It reduces the need for blanket shutdowns. When you can revoke precisely this identity, these sessions, these apps, you stop reaching for the blunt instrument of turn off access for everyone until we figure it out. Precision is how you preserve continuity while you contain. That is resilience, measured in business uptime, not in policy documents. So CAE is not a feature you enable to feel modern. It is a forcing function that makes you prove your trust model is enforceable. Your app estate is compatible with revocation, and your exception culture is governed. If you can't revoke trust quickly, you don't have zero trust. You have conditional chaos with nicer branding. Why adding controls often slows the business. Now here's the part leaders feel in their bones. Every time security improves, the business feels slower. More prompts, more tickets, more waiting, more people saying, I can't do my job. And then the predictable conclusion, security is the department of no. That conclusion is convenient, it's also wrong. The system is doing exactly what it was designed to do. Most organizations add controls the way they add speed bumps, reactively, locally, and without redesigning the road. A phishing incident happens, so MFA prompts increase. A data leak happens, so downloads get blocked. An audit finding appears, so an approval step gets inserted. None of these are irrational, but stacked together, they create a security program that behaves like a queue. Queues create latency. Latency creates workarounds. This is where the real failure happens. The business doesn't break security because it's malicious. It roots around security because security behaves like an obstacle course bolted onto workflows that were never redesigned. People will always optimize for outcomes. If the system blocks outcomes, people will find alternate pathways. And the alternate pathways are never the safe ones. This is also why security teams are stuck in a losing pattern. They add a control. The business adapts. Exceptions multiply. The control loses force. The dashboard stays green because the control exists. But the organization is now operating on a shadow model. What the policies say versus what people actually do to get work done. That distinction matters because leadership often measures security by visible friction. Look, we're blocking risky behavior. Meanwhile, the most dangerous behaviors are now happening invisibly. Shared admin access because approvals are too slow, unsanctioned SaaS because procurement takes months, personal devices because corporate enrollment is painful, or OAuth app consent because it's faster than requesting integration support. Security didn't prevent risk, it displaced it. This is what happens when controls aren't embedded in the way work is done. They become after-the-fact checkpoints, and checkpoints create backlogs. Backlogs create pressure. Pressure creates bypass. Over time, you don't get higher security. You get conditional compliance, people comply when it's easy and evade when it's hard. This is also why just add more approvals is such a dangerous reflex. Approvals feel like governance, but approvals are just decision gates. If those gates are slow, inconsistent, or unclear, you've traded technical risk for operational risk. Now the business can't execute quickly. And when the business can't execute quickly, the business creates its own execution layer. That is shadow-ite, and it is not a moral problem. It is a systems outcome. So why does this keep happening? Because controls are being deployed as independent artifacts instead of as parts of a trust system. Each control is optimized for its own purpose. The combined effect is rarely modeled. Nobody asks the core question, what decision latency are we introducing? And what behaviors will that latency incentivize? Security teams also get trapped by the wrong success metric. If success is reduce incidents, teams will add friction. Friction reduces some incidents, but friction also creates bypass and resentment, which creates new incidents later. It's the same pattern as poorly designed compliance. It produces paperwork, not capability. The better metric is still MTTR, because when you measure MTTR, you get forced to remove friction that doesn't produce containment. You start asking which steps are genuinely necessary and which steps exist because we don't trust our own systems, which checks can be automated and which require humans because the decision is truly business sensitive. That's where automation matters, not as a gadget, but as a way to restore human decision time. Automation doesn't eliminate accountability. It collapses the boring latency. Enrichment, correlation, ticket creation, routing, and reversible containment actions that should not require a human to copy-paste data across tools at 2 a.m. The human should be deciding intent and impact. The system should be executing repeatable mechanics, and the reason leaders should care is simple. When you make security slow, you make the business unsafe. Not because users are careless, because the system taught them that speed requires evasion. So the problem is not too many controls. The problem is controls added without redesigning workflows into safe autonomy. Controls that don't create safe autonomy will always be experienced as friction, and friction is not neutral. It is an entropy generator. If you want speed and security, you don't negotiate with human nature. You redesign the system so the safe path is the fast path. Human behavior is not the weak link. Design is. Human behavior isn't the weak link. That's the story security tells itself when it can't admit the system is poorly designed. People don't wake up wanting to create risk. They wake up wanting to finish work, ship the release, close the quarter, onboard the partner, respond to the customer, unblock the executive. When security makes that harder, people don't ignore policy. They optimize around it. That's not negligence, that's predictable behavior inside a constrained system. This is why blaming users is such a comfortable mistake. It turns a design failure into a training problem. It converts architecture into morality. And it lets leadership believe the solution is another awareness module instead of fixing the way access, workflow, and response actually function. The system creates the behavior, always. If privileged access elevation takes 2 days, people will find a standing admin account. If app onboarding takes 6 weeks, teams will use personal tokens and unsanctioned SaaS. If approvals require 3 different managers, someone will share credentials temporarily, and temporary will become permanent because the business still needs to operate tomorrow. Your policies don't fail because people are bad. They fail because the path of least resistance is the unsafe path. This is where workarounds stop being a human failure and start being system telemetry. A workaround is a signal that the intended workflow doesn't match reality. It's evidence that the control plane isn't aligned with how work actually happens. And when security treats workarounds as insubordination, it guarantees 2 outcomes. Workarounds go underground and the organization loses visibility into its true operating model. Silent non-compliance is the default state of mature bureaucracies. The policy exists, the dashboard is green, the audit passes, the behavior diverges anyway because the system rewards throughput more than it rewards adherence. Meanwhile, the organization tells itself a story. We are secure because we have controls. The attacker enjoys that story. This is also why security fatigue is not a user problem. It's a design problem. If MFA prompts are constant, users learn to approve without reading. If warning banners appear on every email, people stop seeing them. If every request is treated like a crisis, the workforce becomes numb. The control becomes noise, and noise is not protection, it's attacks. A well-designed system doesn't require heroic attention. It assumes attention is scarce and builds guardrails that work even when people are tired, rushed, or distracted. That's not cynical, that's operational realism. So when organizations say people are the weakest link, they're usually describing a mismatch between 2 speeds, the speed of business and the speed of security. Security responds by slowing the business, and the business responds by routing around security. That is the loop. It repeats until either leadership intervenes or the attacker does. And AI makes the mismatch sharper. AI accelerates work. Drafting, coding, summarizing, automating, integrating. The organization's appetite for speed increases. If security remains a manual gate, tickets, approvals, reviews done quarterly, then security becomes the bottleneck that the business will circumvent. Not because it wants to, because it has to. This is why secure by design is not a slogan. It's a requirement for maintaining control when the system's throughput doubles. Design is how you scale trust without scaling friction. Design means the safest path is also the fastest path. Users shouldn't need to choose between compliance and productivity. If they do, they will choose productivity because that's what the organization actually rewards. So what does design look like in this context? It looks like making identity governance and privileged access not only strict but usable. It looks like time-bound access that can be requested and approved quickly with clear accountability. It looks like conditional access policies that are consistent and predictable, not a maze of exceptions. It looks like continuous session revocation, so compromised access doesn't linger. It looks like response workflows that trigger actions automatically, so humans spend time deciding impact, not moving data between portals. And it looks like explicitly designing for failure, assume compromise, reduce blast radius, and make containment normal. If those properties exist, humans don't need to be perfect. The system catches them. The system constrains them. The system corrects quickly when reality changes. If those properties don't exist, humans are asked to compensate for architectural gaps with attention and discipline. That is not a strategy. That is a fragile wish. So stop saying the user is the problem. The user is the environment, and your environment behaves exactly as you designed it to behave. Safe autonomy. The real objective of modern security. Safe autonomy is the objective leaders actually want, even if they keep funding the opposite. They want teams to move fast without creating new existential risks. They want developers shipping, finance approving, sales sharing, and operations running without every meaningful action turning into a security exception or a SOC incident. And they want that speed to be reliable, not dependent on which senior engineer happens to be awake. Security that cannot produce safe autonomy becomes a brake you never tuned. It still slows the car, but it doesn't prevent the crash. It just makes everyone angry on the way there. So define it cleanly. Autonomy means people and systems can act without waiting for a central authority on every decision. It means access is available when needed. It means change is possible. It means the organization can execute. But autonomy without guardrails is just distributed risk creation. Safe autonomy is autonomy with constraints that are dynamic, enforceable, and fast. Dynamic means the control plane uses context, not static assumptions. Identity and device posture, risk signals, session state, resource sensitivity, those inputs shape the decision continuously. If the context changes, the decision changes. That's not a feature. That's the only model that survives modern SaaS and AI-accelerated work. Enforceable means the decision isn't just policy text. It is honored by the systems people actually use. If a privileged role requires elevation, the elevation path has to exist and work. If a session is revoked, the app has to comply. If an access package expires, the access must disappear without negotiation. Otherwise, you don't have governance. You have aspiration. Fast means the safe path is the easy path. This is the mistake security keeps making. It builds a safe path that is correct but slow. Then it acts surprised when the business roots around it. If you want safe autonomy, your control mechanisms must operate at business speed. Access requests must be fulfillable without weeks of tickets. Privilege elevation must be minutes, not days. Revocation must be near real time, not when the token times out. Response must be orchestrated, not tribal. This is also where least privilege stops being a purity test and becomes a design pattern. Least privilege in a safe autonomy model is not you get less access forever. It's you get exactly what you need, exactly when you need it, and it disappears when you don't. Time is the missing dimension in most access models. Add time and the whole system becomes easier to secure without slowing work. Remove time and privileges accumulate until your environment is permanently over-authorized. And autonomy doesn't just apply to humans. Workloads, connectors, service principals, and increasingly AI agents are acting on behalf of the business. If those identities aren't governed, scoped permissions, explicit ownership, rotation, and monitoring, you don't have autonomy. You have unattended authority. That is the fastest way to create a breach with no obvious user mistake to blame. So safe autonomy requires two loops to be built into the platform experience. Loop 1 is the trust loop, signals to decision to enforcement, continuously. This is where Entra governance, conditional access, and CAE live. It's where trust is earned, constrained, and revoked without drama. Loop 2 is the response loop, detection to action to recovery. Because safe autonomy doesn't mean nothing goes wrong. It means when something goes wrong, the system contains it fast enough that the business can keep moving. This is the part leaders often miss. Autonomy increases the number of actions taken without oversight, so the system must be able to correct quickly when an action turns out to be risky. The faster you can revoke, isolate, and remediate, the more autonomy you can safely allow. That's the trade. If your response loop is slow, you will inevitably compensate by reducing autonomy, more approvals, more gates, more centralized control. Not because it's philosophically better, but because it's the only way to reduce blast radius when you can't contain quickly. That is the real reason security slows the business. It is compensating for weak revocation and weak response with human friction. Safe autonomy flips that equation. It says, invest in control plane clarity and response speed so the organization can decentralize execution without decentralizing risk. And the executive level marker that you're building it correctly is simple. Fewer emergency exceptions, fewer escalations, fewer security needs to approve this right now moments. Not because you blocked more, because you designed the trusted path to be the default path. When safe autonomy exists, security stops being a queue. It becomes an operating property of the business. Detection without response is expensive telemetry. Once you accept safe autonomy as the objective, the next failure becomes obvious. Most security programs are built like observatories. They collect signals, they classify events, they generate alerts, then they stop. And then everyone acts surprised when incidents still turn into business outages. Detection by itself doesn't reduce impact, it documents impact. That distinction matters because dashboards are emotionally comforting. A high-severity alert feels like progress. A unified incident view feels like control. But none of it changes the outcome if the organization can't convert signal into action fast enough to matter. This is why so many well-secured organizations still fail. Not because they lacked detection, because they lacked decision speed and enforcement speed. You can think of response as a pipeline with 4 stages: detect, decide, enforce, recover. Most organizations overinvest in the first stage, underinvest in the second and third, and treat the fourth as an annual exercise. So the system behaves like a camera, not like a control system. A camera is valuable after the fact. It tells you what happened. It can help you learn. But it doesn't stop the car from hitting the wall. For that, you need brakes. In security terms, you need orchestration. Consistent, auditable actions that reduce blast radius quickly. The core issue is that response is usually human middleware. An alert fires, it lands in a queue, someone triages it, they copy information from one portal to another, they ask an app owner what the identity does, they ask IT to isolate a device, they ask identity administrators to disable an account, they ask messaging teams to purge an email, they ask someone else to reset credentials. Each step is rational in isolation. Collectively, it's a latency engine. And attackers exploit latency. They don't need to be brilliant, they need you to be slow. This is where leadership gets trapped in the wrong conversation. They ask, do we have a SOC? They ask, are we monitoring? They ask, how many alerts did we close out? Those are activity metrics. They don't tell you whether the organization can contain an identity-driven incident in business time. The question that matters is, how long does it take from first signal to first meaningful containment? Not to a ticket, not to a Slack thread, to containment. Because that's the moment you stop paying compounding interest on the breach. Now, the uncomfortable part, detection without response, is not neutral. It's expensive. It consumes licensing. It consumes storage. It consumes analyst time. It consumes executive attention. And when it's not connected to action, it creates a worse outcome than ignorance. Alert fatigue, where the organization learns to ignore its own warning systems. Once that happens, you have telemetry theater. Lots of data, little control. This is also why more sensors is a weak investment posture. If you add more signals without fixing the response loop, you increase noise. Noise reduces trust. Reduced trust slows decisions. Slower decisions increase impact. That's the loop. It's the security equivalent of adding more gauges to a cockpit while leaving the control surfaces unresponsive. So what does a good response loop look like without turning this into a tool demo? It looks like the organization predefining a small set of reversible actions that can happen fast with clear authority and clear logging. If an identity exhibits a high-confidence compromise signal, the system can revoke sessions, require re-authentication, block risky sign-ins, disable the account, remove standing privilege, quarantine a device, suspend an OAuth app, or route a case to the system owner with context already attached. Not all at once, not everywhere, but as a designed set of bounded responses. Bounded matters because leaders hear automation and picture chaos. Accidental lockouts, business disruption, the wrong account disabled at the wrong time. That fear is rational when automation is built as an improvisation. It becomes less rational when automation is built as policy. Explicit triggers, reversible actions, audit trails, and human approval where the blast radius is large. That is how you turn response speed into a capability instead of a gamble. And this ties directly back to identity as the control plane. If your fastest containment actions live in identity, session revocation, privilege reduction, access blocks, then response becomes feasible. If your containment requires days of coordination across disconnected teams, response becomes aspirational. So the takeaway is blunt. You don't buy resilience with telemetry. You buy resilience by funding the conversion layer between signal and action. And that conversion layer is not glamorous. It's workflow, it's ownership, it's automation, it's rehearsed authority. Without it, you don't have a resilience program. You have a very expensive record of how you lost. Scenario 2, Microsoft Defender, ServiceNow automation. If identity is the control plane and CAE is the revocation muscle, then this scenario is the nervous system connection. How signals become coordinated action without turning your SOC into a human API. Microsoft Defender gives you signal, ServiceNow gives you execution. Most organizations own both categories of tooling, but treat them like separate religions. Security detects, IT operates, and the business waits. That separation is where MTR is born. Defender is already doing aggregation across endpoint, identity, email, SaaS, and cloud activity. It can correlate activity that looks unrelated in isolation. A risky sign-in, a suspicious mailbox rule, an endpoint alert, an OAuth app consent, a new admin role activation. The value isn't that any single alert exists. The value is that the platform can form an incident story without asking an analyst to manually stitch it together. But correlation doesn't contain anything. Containment happens when the organization executes a bounded set of actions fast, with clear authority, and with an audit trail that survives the post-incident review. That's where ServiceNow becomes useful, not as a ticket factory, as the system of action that codifies decisions, approvals, handoffs, and remediation steps in a way that is repeatable under stress. The simple version is Defender detects and enriches. Service now routes and governs. Automation executes the first response steps. Humans handle the exceptions and the irreversible decisions. That's the 10-80-10 model in practice, without pretending the platform can replace judgment. So what does good automation look like here? It looks like defining a small number of playbooks that are intentionally boring. When Defender raises a high-confidence identity incident, the system can automatically create a ServiceNow security incident with the right context already attached. Affected identity, impacted assets, correlated alerts, timestamps, and suggested containment actions. No copy-paste, no what's the UPN, back and forth. No analyst spending 20 minutes collecting screenshots for a ticket nobody will read. Then automation does the first reversible moves. Reversible means you can undo the action without negotiating with half the organization. Re-authentication prompts, session revocation, blocking risky sign-ins, disabling a single account, removing a role activation, isolating a device, quarantining an email, suspending an OAuth app consent, depending on what signal fired and what authority you've pre-approved. This is the key leadership decision. Which actions are allowed to happen automatically and under what confidence threshold? If everything requires a human, you get latency. If everything is automated, you get accidental outages and political backlash. The only stable model is a tiered model. Automatic containment for high confidence, low blast radius actions, human approval for high blast radius actions, and explicit escalation when the system can't determine impact. ServiceNow is where that tiering becomes enforceable. It can embed approval workflows, enforce segregation of duties, and ensure every exception has an owner and an expiration. It can also track recovery tasks as actual work, not as tribal knowledge, credential resets, access review triggers, device re-enrollment, application owner confirmation, customer communications, and post-incident backlog items. That last part matters. Most organizations can contain when the right people are awake. They can't recover consistently because recovery is treated as cleanup, not as an engineered loop. Service now forces recovery to be legible: tasks, owners, deadlines, evidence. Now, the counterintuitive part. This automation isn't about speed for its own sake. It's about restoring human decision time. Humans should decide intent. Is this identity business critical? Is this activity expected? Do we accept the risk? Do we shut down a workflow? Do we notify customers? Do we escalate to legal? The system should execute mechanics, collect data, correlate, create the case, route it, apply reversible containment, and maintain the audit trail. If your analysts are doing mechanics, you don't have a SOC. You have a very expensive workflow gap. And the reason this scenario belongs in an executive briefing is that it changes what leaders fund. Instead of buying more detection, you invest in the conversion layer: integrations, playbooks, ownership models, and rehearsed authority. You build the muscle that turns "we saw something" into "we contained something." Because the board doesn't care that you detected an identity incident at 2:03 a.m. They care whether the attacker still had access at 2:33 a.m. This is also where you stop measuring success by ticket volume and start measuring it by decision latency. Time to detect, time to decide, time to enforce, time to recover. ServiceNow gives you the workflow timestamps. Defender gives you the signal timestamps. Together, they give you the only metric that matters. MTR becomes visible. And once MTR is visible, leadership can actually manage it. Resilience is an operating capability, not an incident plan. Resilience is what the organization can do on a bad day without improvising, not what it wrote down in a binder 2 years ago. Most enterprises have an incident response plan. It exists, it has owners, it has a PDF, it satisfies audits. And it fails at the exact moment it's needed, because plans don't execute themselves and stressed humans don't behave like flowcharts. An incident plan is documentation. Resilience is an operating capability, practiced, funded, measured, and continuously improved. It lives in the muscle memory of teams and the design of systems, not in the phrasing of a policy. This is the uncomfortable truth. Modern incidents are not puzzles. They are time games. The attacker's advantage is not brilliance. It's that your organization needs a meeting before it can act. Resilience is the decision to remove that meeting from the critical path. So, resilience engineering starts with one stance: expect failure, not as pessimism, as design input. You assume an identity will be compromised. You assume a token will be stolen. You assume an OAuth app will get consented. You assume an admin will make a mistake. Then you design for bounded failure: small blast radius, fast revocation, and recovery that doesn't require heroics. Bounded failure is the opposite of prevention fantasy. It's not nothing bad happens. It's bad things happen and the organization keeps operating. That implies 3 capabilities leaders can actually fund. First, containment readiness. This is the existence of kill switches that work. Rapid account disablement, privilege stripping, session revocation, conditional access escalation, device isolation, and application-level blocks, pre-approved, auditable, and reversible where possible. If containment actions require ad hoc approvals, you don't have containment readiness, you have hope. Second, recovery readiness. Containment stops the bleeding, recovery restores the business. Most organizations skip designing recovery as a system, so they pay for it in chaos. Recovery readiness means the organization knows how to restore access safely, rebuild trust in identities, and re-establish clean operating conditions. Credential resets with verification, reissuing tokens, validating device posture, re-onboarding service accounts, verifying that privileged roles are clean, and proving that logging and controls are still intact. If the org can't re-establish trust quickly, it will either stay offline too long or come back online too early. Both are expensive. Third, learning loop discipline. Resilience isn't we survived. Resilience is we survived and we made it harder next time. That requires turning incident lessons into owned backlog items with deadlines, not we should review access, not we should tighten conditional access. Specific changes, which entitlement gets rescoped, which exception expires, which workflow becomes automated, which app must support CAE, which privileged role gets moved to eligible only, which detection trigger now routes to action. This is where most programs rot. The incident becomes a post-mortem presentation, not an engineering input. Now, to make this real, leaders need to stop treating tabletop exercises as compliance theater. A tabletop isn't a quiz, it's a rehearsal of decisions. Who has authority to disable an executive account? Who can revoke access for a third-party integration that drives revenue? Who can force re-authentication for a business-critical SaaS app? Who can approve isolating a device used for production deployment? Who talks to legal? Who talks to customers? Who owns the timeline? Those are not technical questions. They are governance questions under stress. A good tabletop produces 2 outputs: decision clarity and remediation backlog. If it only produces "we learned a lot," it produced nothing. There's also a structural implication to resilience that security teams dislike admitting. Resilience requires alignment between identity, IT, and the business, not cooperation, alignment. Because response actions always affect operations. If the business refuses disruption, the attacker gets persistence. If security refuses accountability, the business gets chaos. Resilience is the negotiated operating model that makes decisive action possible without endless escalation. And AI doesn't change this, it accelerates it. AI makes attacks faster, but it also makes defense more scalable if the organization has the workflow to convert signals into action. Without that, AI just increases the volume of insights you fail to operationalize. So resilience isn't the binder, it's the loop. Contain, recover, learn, repeat it until the system becomes harder to break than it is to run. And once you treat resilience as an operating capability, you can finally put it on a scoreboard leadership understands. The leadership metric, reduce MTTR for identity-driven incidents. This is where leadership usually asks for a dashboard and security hands them the wrong one. They get counts. Number of incidents, number of blocked sign-ins, number of risky users, number of alerts closed. That's activity. It's not capability. Capability is what happens when an identity-driven incident is already in motion and the business is bleeding time. The only metric that translates cleanly from security to operations to the board is MTTR, mean time to respond end-to-end, not time to create a ticket, not time to acknowledge. Respond means containment has occurred and the attacker's ability to act has been materially reduced. If you can't define that moment, you can't manage it. That distinction matters. Identity-driven incidents dominate business impact because identity is the permission fabric for everything else. When an endpoint is compromised, you might lose a machine. When an identity is compromised, you can lose data, approvals, code, financial workflows, and the ability to trust your own systems. It is the difference between a local fire and a fire in the building's electrical panel. So the leadership mandate is simple: reduce the time window in which a compromised identity can operate. The 40-60% reduction target is not magic. It is the difference between a system that relies on humans to stitch context together and a system that treats identity as a control plane with enforcement and workflow. If your current MTTR is measured in hours, cutting it roughly in half is entirely plausible when you move the first actions from manual to orchestrated and when you stop waiting for token expiry to do your job. But leaders need to understand what they are actually measuring. MTTR is not a single stopwatch. It's a chain, and chains fail at the weakest link, so break it into 4 timestamps that are board legible and operationally honest. Time to detect. When did the system first have a credible signal that something was wrong? Not when someone looked at it, when it existed. Time to decide. How long did it take for a human or a policy engine to decide this is real enough to act? This is where alert fatigue and unclear severity definitions turn into business exposure. Time to enforce. How long did it take for the decision to change reality? Disable the account, revoke sessions, block the sign-in, remove privilege, quarantine the device. If it took 2 hours to get approval, that's not governance, that's latency. Time to recover. How long until the business can operate safely again? Not we stopped the attacker. We restored trusted access and verified the control plane is intact. That model gives leaders something they can fund because each stage has different blockers. Time to detect is usually a signal coverage and correlation problem. Defender and Entra can help, but only if the environment is instrumented and identity signals aren't treated as optional. Time to decide is usually a clarity problem. Who owns the call, what thresholds matter, and what actions are pre-approved. Ambiguity is the most expensive security control you can deploy. Time to enforce is an architecture problem. If revocation depends on token expiry, you chose slow enforcement. If enforcement depends on 3 teams and a meeting, you chose slow enforcement. CAE and privileged access governance exist to collapse this gap. Time to recover is an operating model problem. If recovery is ad hoc, it is slow by design. If recovery tasks are templated, owned, and automated where possible, it becomes repeatable. Now here's what blocks MTTR improvement in real organizations. Unclear authority. Nobody wants to be the person who disabled the CFO's account during quarter close, so they escalate until the attacker is done. Manual handoffs. Signals move from defender to email to chat to ticket, with context lost every time. Exception sprawl. The most critical identities and apps are often the most exempt, which means your highest risk pathways are your least governable ones. An entitlement ambiguity. If you don't know what an identity can do, you can't contain it confidently. You hesitate, the attacker doesn't. So leadership should treat MTTR like a resilience KPI, not a SOC KPI. It's how you measure whether the enterprise can make trust decisions and enforce them in business time. Everything you funded earlier, Entra governance, ITDR discipline, CAE, and Defender to ServiceNow orchestration should show up here as lower decision latency and faster enforcement. And if it doesn't, you don't have a tooling problem. You have an operating model that still confuses visibility with control. Composite incident, same tools, different outcome. Now put all of this into a story that leaders recognize. Not a named breach, not a vendor fairy tale. A composite incident built from the same patterns every SOC and identity team has seen. Session abuse, over-permission, slow revocation, and manual response. Same organization, same Microsoft stack, same green dashboards. 2 different outcomes determined entirely by design. In the first version, the attacker doesn't start with some exotic exploit. They start with an identity that has more authority than anyone remembers approving. A contractor account, a partner identity, or an internal user who moved roles 3 times and kept access every time. The initial foothold is boring. A captured session token via a malicious browser extension, a convincing OAuth consent, or straight credential theft followed by MFA completion. It doesn't matter which because the system's failure mode is the same. The user successfully completed MFA, so the attacker doesn't fight authentication. They inherit it. From there, the attacker explores entitlements. They don't need to scan networks. They just enumerate what the identity can reach. SharePoint sites, Teams files, mailbox rules, Power BI workspaces, Azure resources, third-party SaaS. They look for the same things every attacker looks for. Export paths, admin paths, and trust paths. Here's the weird part. Most of this activity doesn't look like malware. It looks like a busy employee. Downloads, list operations, API calls, role lookups, consent grants, maybe a few impossible travel hints, but nothing that screams ransomware, so the organization stays calm. Defender sees signals. Entra sees risky behavior. The logs are there, but the decision loop isn't connected to enforcement. So what happens is the most common failure mode in identity incidents. People notice, but nothing changes fast enough to matter. A ticket gets created. An analyst pings the identity team. The identity team asks the business owner whether the account is critical. The business owner isn't sure. Someone schedules a call. Meanwhile, the attacker keeps operating because the session remains valid. Tokens don't care about meetings. Then the attacker finds the real value, an identity pathway that can change control, a role that can read security settings, an account that can create new app registrations, a service principal with broad graph permissions, or a legacy admin group nobody reviews. Now the incident stops being suspicious user behavior and becomes a business event. Data exfiltration, control disablement, or persistence creation. And the root cause later reads like a checklist of comfortable truths. MFA was enabled. Defender generated alerts. We had logging. We followed the process. Yes, and the attacker had time. Now rerun the same incident in the redesigned environment. Same tools, different outcome. The attacker still gets the initial token. That part is not fantasy. Assume breach, but the identity is governed differently. The access is time-bound. Privilege is eligible, not standing. Entitlements have owners, and the first meaningful actions don't require heroics. The first sign of risk elevates the account state. Entra's identity signals change the trust decision. CAE forces re-evaluation inside the session. The attacker's borrowed trust collapses while they're still trying to explore. Not because someone woke up faster, because the platform revoked trust in business time. At the same moment, Defender correlates the incident and pushes it into ServiceNow with the context already attached. Identity, device, SaaS artifacts, and recommended containment. ServiceNow isn't used to start a conversation. It's used to execute a predefined response path. Automation takes the reversible steps immediately. Revoke sessions, block risky sign-ins, remove active privileged role assignments, isolate the device if needed, suspend suspicious OAuth grants if they exist. Humans still decide the big calls. Do we disable the account entirely? Do we pause a business workflow? Do we notify legal? Do we trigger broader access reviews? But humans are deciding while the attacker is contained, not while the attacker is still active. That is the entire difference. In the first environment, trust drift and decision latency turned a minor identity compromise into an enterprise incident. In the second, the attacker still got in, but they couldn't stay, couldn't escalate, and couldn't move fast enough to make the event existential. Same tools, same tenant, same budget line items, different outcome, because the organization stopped measuring security by coverage and started engineering it as a control loop, identity governance to reduce reckless entitlements, CAE to revoke sessions when reality changes, and orchestration to collapse the time between signal and action. This is the moment leaders need to internalize. Security isn't the number of incidents you prevent, it's the size and duration of the incidents you allow. The executive operating model for security beyond controls. So if the story is same tools, different outcome, the obvious executive question is, what actually changed? Not the product list, the operating model. Because controls don't run themselves, they are executed through ownership, decision rights, and a loop that converts intent into enforcement. Without that, you're just accumulating features and calling it maturity. Here's the model leaders need to hold in their heads. One loop, end-to-end, identity, trust decisions, detection, response, recovery. Identity is your control plane because it's where permissions live. Trust decisions are the policies that decide under what conditions is that identity allowed to act. And detection is the sensing layer. Response is the action layer. Recovery is the process of restoring trusted operations and proving the environment is clean enough to resume. If any part of that loop is weak, the whole enterprise becomes a probabilistic system, and leaders should stop accepting probabilistic. Now, most enterprises treat each part of that loop as a separate department: identity team, security operations, IT operations, application owners, risk, legal, audit. The attacker doesn't care. So the operating model has to align those pieces without creating a bureaucracy that moves slower than the threat. That starts with a clean split: policy intent versus policy enforcement. Policy intent belongs to the business, not because the business writes conditional access rules, but because the business defines the tolerable risk. Who should have access to what, for how long, with what approvals, and under what conditions? That's governance. That's not an IT preference. That's a business decision about trust. Policy enforcement belongs to the platform teams. Identity, endpoint, and security engineering translate intent into deterministic mechanisms: conditional access, privileged access constraints, entitlement packages, CAE triggers, and automation playbooks. But the key is this: enforcement must be testable. If a policy can't be tested under realistic conditions, it's not a control, it's a belief. The second component of the operating model is exception governance. This is where most programs collapse. Exceptions are not rare edge cases, they are entropy generators. They accumulate because the business is trying to function and because security is trying to accommodate. Over time, exceptions become the real policy, and the real policy becomes theater. So executives need a non-negotiable rule. Every exception must have an owner, a justification, an expiration date, and a review cadence. No expiration means you're not granting an exception. You're redesigning the security model without admitting it, and exceptions need to be treated as first-class risk objects, tracked, measured, and reduced over time. Otherwise, you will always enable CAE, enable governance, enable zero trust, and then quietly bypass it everywhere it matters. Third, decision speed requires decision rights. Identity incidents become expensive when nobody is allowed to act. The SOC sees signals but can't revoke access. It can isolate devices but can't disable accounts. App owners can approve access but don't understand blast radius. Legal wants certainty. The business wants continuity. So define 3 tiers of authority in advance. Tier 1, pre-approved, reversible actions that can happen immediately when confidence is high. Session revocation, forcing reauthentication, blocking risky sign-ins, suspending a suspicious OAuth grant. These should not require a meeting. Tier 2, disruptive but bounded actions that require fast approval. disabling an account tied to revenue workflows, locking down a sensitive SharePoint site, removing privileged access from a production operator. These need named approvers, not the team. Tier 3. Enterprise impact actions that trigger executive incident governance. Broad access shutdowns, customer notifications, regulatory disclosures. These are rare, but if you don't predefine them, you'll discover your authority model in real time. That's not leadership, that's improvisation. Fourth, investment posture. Leaders need to fund the loop, not the sensors. If the organization already detects plenty but still bleeds time, the gap is response orchestration and identity enforcement. That means funding integration work, automation playbooks, entitlement cleanup, and application modernization so that revocation is actually honored. That is not operational detail. That is the only path to reducing MTTR. Finally, accountability, not in the abstract, in the operating rhythm. Every quarter, leaders should demand 3 outputs. Current MTTR for identity-driven incidents, the top 10 exception paths by risk and business criticality, and the backlog of identity and response improvements with owners and dates. If those 3 are visible, security stops being an argument and becomes an upravляемый system. That's the executive operating model. One loop, explicit ownership, governed exceptions, pre-approved actions, and a scoreboard that measures speed of containment. Everything else is commentary. Executive checklist. What to ask your teams this quarter. If leadership wants this to move from security is complicated to security is operated, the fastest way is to ask better questions. Not more questions, better ones. Here are the questions that cut through tooling and land directly on system behavior. First, where do we have authorization risk, not authentication gaps? Don't accept "we have MFA" as an answer. Ask where a compromised identity could still do disproportionate damage because the entitlements are wrong. Who can export data? Who can change sharing settings? Who can create app registrations? Who can grant admin consent? Who can disable controls? If the answer is "we're not sure," that's not a visibility gap. That's unmanaged blast radius. Second, which identities can change systems, data, or controls? Humans and non-humans. This is where most organizations lie to themselves. They can list admins. They can't list service principals, automation accounts, CI/CD identities, connectors, or the new wave of agent identities. If machine identities outnumber humans in your environment, and they usually do, then governing only humans is a decorative security program. Ask for an inventory, ownership model, and rotation posture. If nobody owns an identity, it owns you. Third, how quickly can we revoke access across our critical apps when risk changes? Not, can we disable the user? How quickly can we actually remove effective access in the apps that matter? Email, files, collaboration, ERP, finance, ticketing, code repos, and your top SaaS platforms. Ask for proof, not assurance. Which of these apps honor near real-time revocation signals, and which will keep a session alive until token expiry? If revocation is slow, you are granting attackers time by design. Fourth, how many response steps remain manual and why? This is not a call to automate everything. It's a call to identify the latency you've normalized. Ask your teams to map one identity incident end-to-end and count the handoffs. How many times does context get re-entered into a new system? How many steps exist only because systems don't talk to each other? The goal is not fewer tickets. The goal is fewer minutes between signal and containment. Fifth, what exceptions exist? Who owns them? And when do they expire? Executives are often the reason exception culture survives. So ask for the uncomfortable list. Exclusions and conditional access, bypasses for business-critical apps, accounts that never get access reviewed, service principals with broad permissions temporarily, and privileged roles that stay standing because it's easier. If an exception has no owner and no expiry, it is not an exception. It is the real architecture. Sixth, what is our current MTTR for identity-driven incidents end-to-end? Not a guess, not a slide, a measured baseline. An MTTR broken into detect, decide, enforce, recover. If your teams can't produce those timestamps, they can't improve them. If they can produce them, then leadership can fund the stage that is actually slow, decision rights, enforcement mechanisms, or recovery workflows. Seventh, and this is the one most leaders avoid, who has authority to act and how fast can they act when the identity is politically sensitive? Ask specifically about the hard cases, an executive account, a production deployment identity, a revenue workflow, a third-party integration that a business unit owns, or a service principle nobody understands. In those cases, does the organization have pre-approved actions, or does it have meetings? Because an attacker doesn't care that the identity is important, they care that it is powerful. If you ask these questions and you get vague answers, that is not a failure of the security team. That is a leadership problem. Unclear intent, unclear ownership, and no mandate to reduce decision latency. So don't ask your teams for a zero-trust roadmap. Ask them for proof that the trust model is enforceable, exceptions are governed, and response actions are pre-approved and rehearsed. That is what security maturity looks like when it's real. Conclusion, security as an enabler. Security maturity is safe autonomy plus fast recovery, measured by MTTR, not by how many controls you can list. If you want the practitioner version of this, listen to the follow-up episode where we unpack Entra governance, CAE, and Defender to Service now response loops in plain operational terms. Subscribe to M365 FM and cue that next episode now.